My name is Gavin and I'm a tutor with Wyzant, and today I'll be answering a question that was asked by Anto, which is about um, making a decision about what the best investment is when it comes to like the number of rooms that we should be adding to a hospital. So we can use Microsoft Excel to help us do some calculations and incorporate some probabilities, and hopefully we'll come up with an optimal scenario. So here's the question here. So I'll start with I'll share my screen so you can see. That way you can see the Excel spreadsheet, and we'll switch back and forth between that and this problem. All right, so here's a spreadsheet. So starting with an empty spreadsheet. Okay, so what we have is a hospital that's trying to decide how many new rooms to add to the new wing they're building. Each new room will contain one bed. There are currently 100 rooms. Before we start, we've got 100 rooms already. The hospital already has 100 rooms. Now, each new room will cost $80,000 each, which will cover construction and equipment. They're considering adding anywhere between from 100 to 300 additional rooms. And we won't consider in between amounts. We'll just add either 100, 200, or 300. So looking at this, how are we going to set this up? Well, in Excel, there are a lot more rows than columns. So we need to look at 3 different scenarios, or maybe even 4 scenarios, like the case where we don't do anything. And then we'll look at a number of facts. So since there's only 4 scenarios, we'll probably put each scenario in the column. So there's number of new rooms, to add, and we could either add 0, 100, 200, or 300. So since there's only 4 scenarios, then we'll use each column will be a scenario, and generally going down, there's going to be a lot of different things we're going to be calculating for each scenario. So, and there's a lot more rows. So that's why I decided to do this way. You can go the other way if you want, but this is I think this is the easiest way to arrange our information. Okay, number of new rooms to add. Okay, and so this will be the total number of rooms after the investment. So that means we'll basically have that. So it's equal to the cell above plus the initial number of rooms, 100. So copy that across. So that means if we don't do anything, we'll still get 100 rooms. If we add 100 rooms, we should have 200. If we had 200, we'll have 300. If we had 300, we'll have 400 because we're starting with 100. Okay. Now, each new room will cost $80,000 for construction and equipment. So cost, construction and equipment. It's going to equal $80,000 for every room times the number of rooms that we're going to be adding. And that's going to be a monetary amount. Okay, so here we are. So we add 100 rooms, it's going to cost 8 million. 200 rooms will cost 16 million, 24 million. Okay. We can even cross out information we've considered. Room contain 1 bed, 100 the current 100 rooms, so we've considered that. 8,000. Okay, they're considering adding in between. Okay, we've done that. In increments of 100. 3 possible investment possibilities. Okay, in addition to the per room construction costs, there is also an additional investment cost of $3 million for any additional rooms, no matter the number of rooms. So that's like a fixed cost. There's another cost called the call it an investment cost. Which is a fixed cost. Okay, so we can see that for if you don't add any number of rooms, then it's going to be 0. But if you add rooms, it's going to be 3 million. Okay, so we can copy that. And we'll make all those monetary. That's our fixed cost. The decision to build is based on comparing 1/10 of this investment to some annual contribution to investment. Okay, so let's look at the total investment. The total cost is the total investment. So we're just going to sum the previous 2 rows. Okay, so we have either 11, 19 or 27 million. Now, it says we need to compare 1/10 of this investment to some annual contribution to investment. For instance, if 200 rooms are added, then you can think about the $19 million investment as a 1.9 million annual cost. Suppose this was compared to an expected annual contribution of 2.1 million, then there would be an annual surplus of 200,000. The hospital wants to make their decision based on the highest expected annual surplus, with a decision not to build anything having a $0 contribution. So that paragraph, I don't fully understand that paragraph just yet. Let's go to the next part. So it says, if hospital decides to build 100 rooms, it is determined that there are 2 possibly future outcomes. A low case with probably 0.25 and a medium case probably 0.75. So we can put that in for the moment. So so this is called a low case probability, medium case probability, and a high case probability. So the probabilities, so it says for 100 rooms, it is determined that there are 2, just low and medium. Low is 0.25 probability, medium is 0.75 probability. So that adds up to 1, so that must be 0 chance of a high case. There'll be no high case here. Yeah, if the hospital decides to build either 2 or 300 rooms, it has determined that there are 3 scenarios, 3 possible cases. Low with 0.20. Oh, so that was for 100 rooms, isn't it? Yeah, so I managed to have to move those. That's for the so it's so 0.2 for this probability for both 200 and 300. Medium is 0.65, and that the remaining probability. Okay, so we can see that 0.2 plus 0.65 is, I guess we can even use Excel to do this calculation. It equals 1.0 minus that one minus that one. And copy that formula to there. Okay. So now the total probability should be 1 for each of those. Again, you can use Excel to check that if you want. That should be equal to 1. And there's a sum, auto sum feature. Yep. And we can copy that across. Okay. So now we know about the probabilities. We can cross this out. If they build 100 rooms, the contribution used for analysis is 1.4 million for the medium case. Okay, so contribution, so the contributions, all right, we'll have low case, medium case, and high case. We can indent these since we put a heading there. Now for 100 rooms, for the low case, 1.4 million. We're going to stick to dollars here, so let's make all these dollars. Yes, that's 1.4 million. If they build 100 rooms, oh, that's for the medium case. So I got that wrong there. That was, I need to move that to the medium case. And I believe it was, oh yeah, because when I shifted that, I cut it, that's why I lost the formatting there. Okay, that's 1.3 million. Okay, so yeah, if they build 100 rooms, it's 1.4 million for the medium case. Yep. 1.3 million for the low case. There's no probability for the high case. Now, if they build 200 rooms, the contribution used for analysis is 2.5 million for the high case. $2.3 for the medium, and 1 million for the low case. for 200 rooms. Finally, if they build 300 rooms, it'll be 3 million 2.8 and 700,000. What decision should they make about adding rooms? How many? Okay, so the question is, how many should we be adding? 0, 100, 200, or 300? Well, so the last thing we do is understand this paragraph here. And as you can see, these cases look like, high case means you get more money back, medium case, low case. It looks like these contributions are some kind of return on investment. And these are annual returns, I guess, because it did say that these contribute. Yeah, so and the reason why we have high, medium, low is because we don't know what the future holds. There's a chance that there's a small chance, a 15% chance that we're going to be getting a high return on investment. There's a big chance we'll be getting a medium return on investment, which will be these figures. And then there's a small chance we'll be having a low return on investment here. Let's read this paragraph again. It says, the decision to build is based on comparing 1/10 of the investment to some annual contribution to investment. For instance, if 200 rooms are added, then you can think about the 19 million investment as a 1.9 million annual cost. Okay. So what they're saying here is if you got the total investment is 19 million, but you can also think of that as an annual cost. Which will be 1/10 of that. I think what they're saying here is that okay, it's a 19 million total cost, but to break it up into sort of a per year cost, it's going to be 1.9 million if you go for the 200 room option. And now that it's converted to an annual cost rather than a total cost, you can now compare them with these guys to see if we have a net profit. Because if the annual cost is bigger than the expected annual return, so these are like annual returns, then compare apples with apples there, because they're both annualized. Then having something negative is going to mean the cost is bigger than. So let's do that. Let's work out the expected. This has actually got probability in it, where the expected outcome is a product of the probabilities times the contributions for each of those probabilities. So we can call this expected contribution. Expected contribution. This is like the expected return per annum. Okay, so what happens is we've got 0.25 chance we'll have that return if you go 100, plus you'll also get a 0.75 chance times that, plus that one times that. So we can actually use the sum product function here. Hang on, the sum, we want that times that plus, yeah, so it's a sum product. So it equals sum product of these three probabilities with these three here. Convert that to currency. Yeah, and you can also verify it another way. You can just say it's equal to 0.25 times what you get plus 0.75 times that one. And there's no point doing the third one, although it is being done by the sum product, but that's fine. Adding 0 doesn't change it, so it'll get the same answer. This is correct, so we can delete that one, use the sum product formula because that looks like a more efficient way to write it. Okay, here we go. So okay, so expected contribution there. So now these are the expected annual contribution or annual return on investment for each of these scenarios, which takes into account the fact that these have different probabilities. So now we can look at the profit. So the profit is just going to be equal to what you're expecting to get back on average minus how much it costs when we consider it on an annual basis. So we're actually getting a profit there. Okay, so option 3 is a loss actually, because in parentheses means it's negative, so that's negative 2,900. So you're paying 2.7 million per annum, but only getting back on average 2.4 million. That's why it's a negative. Here we're going to be gaining 170,000. Here we're gaining 275,000. So if I would say that profit is going to be our key goal here to maximize. So this option is the best option here, and here we have 0, which is actually better than negative. So okay, so this is our best option here. So we'll highlight this column. And that's, so 100 is the answer. Our best option is to add 100 rooms because based on the annual cost versus the expected contribution per annum, we're going to be getting our biggest profit. All right. That concludes this, and thank you for listening.